Hey, it's Paul Browning here. So welcome to Cisco CCNA in 60 days. The book is on Amazon if you want the book to accompany the course here on YouTube. It's version 4 you need. Otherwise, please subscribe to the channel, hit the like button, and there's a bell icon which makes sure you get all the videos high up on your feed so you don't miss a day. This is day 11 and we're covering ether channels. Now, I can't remember if it's specifically mentioned in the syllabus, but everything I cover would be in the exam. For some reason, some things that are tested in the exam aren't in the syllabus, so I still have to include them. I know some people ask why I'm covering certain topics. Read the cram guide, review yesterday, watch yesterday's videos, do yesterday's labs and today's videos and labs as much as you can. Take today's exam. Do subnetting for about 15 minutes. Today's ether channels theory and then a hands-on lab. There's a few questions they can ask you in the exam. They always tend to ask the same ones to catch out, to see if you can understand the different types of ether channels being used. So you need to absorb all of the theory in the lab. If you want to grab a couple of books that will help you, there's 101 Labs IP Subnetting and then IP Subnetting from Zero to Guru. So that's all for today. Best of luck with the videos. I'll see you tomorrow. Okay, welcome to our brief chat about ether channels. It's another subject that's dropped from the CCNP into the CCNA. So what I've done is taken the core concepts from the CCNP switch and just taken out some of the fundamentals and configuration commands so we understand the basics. I don't think they're going to go into a deep dive when it's covered again in the CCNP. So we'll cover enough that we need to know, and so we're comfortable understanding how it works and how to do a basic configuration. And there's a lab also. So ether channel basically is a way to group two or more physical links on your devices. So say for example you've got two switches, and what you can do is aggregate. Obviously you're connecting the interfaces together with, for example, Ethernet cables, and what you're doing is aggregating these interfaces together, so two or more interfaces physically act like one logical interface, so you can pass more traffic over the interfaces. It is the main benefit. You can create ether channels out of fast Ethernet or gigabit Ethernet interfaces. Also very useful for redundancy, and even though you've got, say for example, 4 physical links and 1 ether channel created, it allows the traffic to be load shared over all 4 links. You can create layer 2 or layer 3 ether channels. We're just going to look at layer 2 for this presentation. So this is what I've sort of explained in verbal format, and I've put it here now in visual format, so it probably makes more sense. And there's that difference between what you can see and what the network can see. What we can see is the physical view, what the network can see is the logical view. So ether channels, do's and don'ts. Each ether channel consists of up to 8 physical ports. Check your iOS and your platform, because you can the more robust and higher level of Cisco switch you have, the more features it will support. The important thing, and this is a classic exam question where they could try and catch you out, they must share the same characteristics such as VLAN, speed and duplex. Your ether channel will not come up, the port channels will not come up if your interfaces physically have been put into different VLANs, the speeds don't match and the duplex doesn't match. And again, I've already said, just check your iOS and Cisco documentation for what's available on your model. Now, another classic thing, I'm just trying to think of things I could ask questions about. Spanning tree treats the channel as a single interface. Protocol options, so 2 main ones are port aggregation protocol, which is PAGP. I'll come to the other one. Oh, LACP I've put on this slide as well. So Cisco own PAGP, but the open standards IEEE created LACP, Link Aggregation Control Protocol. Worth noting down the specification 802.3 AD. PAGP modes include on, auto, and desirable. So this could remind you of this dynamic trunking protocol, where you've got one side could be passive and the other side could be active. Just bear in mind that one side needs at the very least to be in active mode, and the other side could be in passive mode then in order for the channel to come up. If both sides are in passive mode, whichever the configuration command is, then you won't have a channel come up. So here's a table that you need to basically memorize, but it's just summarizing what I've said. You must have at least one side in desirable mode for the channel to come up. Packet forwarding, these are classic exam questions as well. Dynamic trunking protocol and Cisco discovery protocol, they can send the receiver over all interfaces. If you've got a trunk port, PAGP frames are sent on the lowest numbered VLAN. Spanning tree always chooses the lowest operational port in the Etherchannel bundle. So make sure you know these facts, because these are the sort of things I reckon they could ask you in the exam. I've put down an output for Etherchannel, show Etherchannel summary and STP, just to reinforce the last point. We'll go over the first active port. It's a trick question, so if the first port's down, it will go over the next active port. CDP and DTP will go over all operational ports there. LACP does not support half duplex, but it's active mode and passive mode in this. So there's no sort of desirable mode. So just bear in mind what the commands are, because this is a classic question as well. And same rules as with PAGP. Configuration commands are here, but we're actually going to do a lab. I'm going to do a lab on Packet Tracer. You can do Etherchannel and Packet Tracer, however, you've got a lot more limitations of the commands and outputs and show commands, as you'd expect, I guess. But make sure you're familiar with all of these commands and how to configure a basic Etherchannel group. You can see the output, and you can see the port channel is up. The S is layer 2. The U stands for in use. Protocol is PAGP, and the port status, capital P in brackets, is in the port channel. So an important command for you to remember, and we're going to be doing this in the lab. Welcome to our Etherchannels Lab. It's on Packet Tracer, and I've just connected Ethernets, fast Ethernets 1 to 4 on 2 switches, so fast Ethernet 0/1 through to 4. So if we go into the left-hand switch, I'll configure the interface range, and again bear in mind all parameters need to match on both sides in order for this Etherchannel to form. I've made mistakes before where I've had interfaces in different VLANs from an old config. Layer 3 switch, you need to type switch port and then press enter. But this is a layer 2, so switch port mode access. You can leave the ports in VLAN 1 if you wish, but I just thought I'd change the VLAN just to illustrate my point. So all interfaces are now in VLAN 2. And this is the key command, channel-group. Choose a number as long as they match both sides, and I press the question mark so you see all your choices. On is the default mode. It's not really a PAGP mode, but it will enable the interfaces to be bundled. For LACP, you've got active and you've got passive. Now, as I said on the theory presentation, at least one side must be in active mode. For PAGP, you've got auto and desirable. So remember the different modes for the different protocols, because this is a classic exam question. So when you come to do the lab, obviously try the different modes for the 2 protocol types. I'm just going to illustrate one. Alright, so on the neighbour switch, same configuration basically. So on this side, channel group 1 again, and I'm going to choose mode passive. So one side's active and the other side's passive. Now if you've made a mistake, you'll see your port channel come up, but then it'll go down again if there's a configuration mistake. So you can see interface port channel 1 has come up there, some of the outputs cut off. So it's created a port channel interface. You don't have a lot of outputs for the show ether channel on Packet Tracer. So show ether channel, I'll just hit enter here. Show ether channel summary is quite a handy command. Just have a look at what the summary letters mean from the key above. Port channel 1 is up, layer 2. The S and U is in use. Protocol's LACP, and you can see the ports to the right that are in the port channel groups, Fast Ethernet 1, and the far right hand side is Fast Ethernet 4. So this will indicate if there's any issues. I'll just type some of the other commands out. I don't really think you're going to be asked about any of these other commands because we're not going into any complex areas of ether channel. You can't, I've tried this command, you can't use it on Packet Tracer. So there you go, pretty much come to the end of the lab. So you've seen how to configure an ether channel. I recommend you learn how to do this, and obviously same with all the other labs, make sure you can configure it without me there to show you how to do it, and you try all of the available protocols. I just wanted to show you the port channel that's been created as well. You can't, unfortunately, you can't do a show command on the port channel on Packet Tracer. I try and do it now, it doesn't let me. But you can see, at least you'll see the status of the port channel, which is up in this case, obviously.